Ever feel like time is slipping through your fingers? Like it's a river, always flowing.
Yeah.
What if I told you that river isn't as straightforward as it seems?
Hmm.
Get ready to dive into the mind-bending world of time relativity. We're exploring excerpts from Time is Relative Literally, a fitting title. Well, time is literally relative.
It's wild to think about for centuries. I mean, we just assumed time was this universal metronome, ticking at the same rate for everyone, everywhere. Then comes Einstein and just throws that out the window.
Okay, so let's unpack this. The first mind-blowing concept is time dilation. Imagine this. The faster you move, the slower time passes for you compared to someone standing still.
Right.
I know. It sounds like something out of a sci-fi movie, but stay with me.
It's not science fiction. It's been proven. In 1971, scientists took atomic clocks, super accurate timekeepers, put some on jets that flew around the world, and left others on the ground. When the jets landed, the clocks that had been flying were ever so slightly behind. Time had literally moved slower for them.
So if I were to blast off in a spaceship, near the speed of light, time would slow down for me relative to everyone back on Earth.
Right.
I'd age slower.
Exactly. You'd essentially be taking a one-way trip to the future. While years pass for everyone else, you'd experience just a fraction of that time.
Right.
It's like hitting fast forward on everyone else's life while you're moving in slow motion.
Okay, my brain is already starting to melt a little bit, but wait, there's more, right? The excerpts also talk about gravity messing with time.
Absolutely. Think of massive objects like planets and black holes as cosmic bowling balls on a trampoline.
Okay.
They warp the fabric of space-time around them.
Right.
This warping isn't just a visual. It actually causes time to slow down in regions of strong gravity.
So if I were hanging out near a black hole, time would move differently for me compared to someone farther away.
It wouldn't just move differently. It would crawl. Imagine looking up from the edge of a black hole at someone far away.
Yeah.
You'd see them aging rapidly while you'd barely age at all.
Wow.
It's mind-boggling, isn't it?
Totally. But it makes you wonder if gravity can affect time like that.
Yeah.
Doesn't it mean our everyday experience of time is also warped, even if it's subtle?
That's a great point. Even here on Earth, gravity isn't uniform.
Right.
Time actually passes slightly slower at sea level than on a mountaintop, where gravity's a bit weaker.
Right.
It's such a tiny difference that you'd never notice it in your daily life.
Yeah.
But it's there.
Wait. So you're telling me that my feet are technically younger than my head?
Well, that's hilarious.
It is funny when you think about it like that,
Yeah.
but it highlights just how pervasive the effects of relativity are.
And it's not just theoretical. These principles have real-world applications.
Oh, right. The excerpts mention GPS satellites, don't they? How does relativity affect them?
GPS satellites orbit Earth at high speeds and are farther from its gravitational pull. Because of this, their clocks actually run slightly faster than clocks on the surface. It might seem like a minor detail, but without accounting for this relativistic time difference, GPS systems would be widely inaccurate.
Hold on. So our phones rely on Einstein's theory of relativity to navigate us to the nearest coffee shop.
They absolutely do. Without factoring in the time dilation caused by both speed and gravity, your phone would think you're miles away from where you actually are.
Wow.
Imagine the chaos. It's amazing to think that something as seemingly abstract as time relativity is woven into our everyday technology.
Okay, let me recap this because we covered a lot of ground. Time isn't this rigid, unchanging thing. It's affected by speed and gravity, creating different experiences of time for different observers.
Yeah.
We've got time dilation, making astronauts age slower, and GPS satellites needing relativistic corrections.
Precisely. And all of this is just the tip of the iceberg. It leads us to even more mind-bending questions like, is there a universal now? Does everyone experience the present moment at the same time? And if not, what does that mean for our understanding of reality?
Whoa, that's a deep thought. I think I need a moment to let all this sink in. But before we go there, I have to ask, the excerpts mention something about time travel. If time is relative and can be warped, does that mean we can actually travel through time?
Time travel, huh? Well, according to Einstein's theories, it's not as far-fetched as you might think, but let's break it down, shall we?
Please. I'm all ears. I need to know if I can finally visit the dinosaurs
Aha!
or hop into the future and see what gadgets they've invented.
Okay, so traveling to the future, that's actually more feasible, at least in theory. Remember time dilation. If you could travel at speeds approaching the speed of light,
Right.
time would slow down for you relative to everyone else. Return to Earth after, say, a year of super speed travel.
Yeah.
And decades would have passed for everyone else. You'd literally step into the future.
So it's like a one-way ticket to the future.
Yeah. Yeah.
Sign me up.
Yeah.
But what about going back in time? Visiting those dinosaurs. Is that even remotely possible?
Well, that's where things get even trickier. The excerpts touch upon something called wormholes.
Mm-hmm.
Imagine folding a piece of paper in half and poking a hole through it.
Okay.
That hole connects two distant points on the paper. Right?
Yeah, I'm following so far.
Theoretically, a wormhole is like that, a shortcut through space-time,
Right.
connecting two distant points in the universe, potentially even different points in time.
Wait, so you're saying wormholes could be like time portals? Has anyone ever actually found one?
Here's the catch. Wormholes are still purely theoretical. We've never observed one directly, and even if they do exist, they might be incredibly unstable, impossible to traverse. Think of it like trying to walk through a soap bubble. It pops before you can even get close.
Okay, so time travel to the past is still firmly in the realm of science fiction for now. Bummer.
Mm-hmm.
But I guess it's cool that relativity even allows for the possibility, right?
Absolutely. And who knows what the future holds? Maybe one day we'll unlock the secrets of wormholes,
Right.
and crack the code of time travel. But even if we can't physically travel through time,
Right.
relativity completely challenges our understanding of it.
You're right. We were talking about the concept of a universal now earlier. Can you elaborate on that? If gravity and speed can warp time.
Yeah. Does that mean everyone's experience of now is different?
Hmm.
Exactly. Relativity shatters the idea of a single universal present moment. Imagine someone on a distant planet orbiting a massive star.
Yeah.
Their experience of now would be different from yours.
Yeah.
Because of the differences in gravity and relative motion. It's as if everyone has their own personal now bubble.
Whoa, hold on. So even as we're having this conversation,
Yeah.
our individual experiences of now are slightly different.
Mm-hmm.
Is my now lagging behind yours? This is messing with my mind.
It's a wild concept, isn't it? It makes you rethink the very fabric of reality. It suggests that the universe is a lot more complex and nuanced than we might perceive in our everyday lives.
And that brings us to another mind-boggling concept, the block universe. You mentioned it earlier.
Yeah.
Can you explain what that is? It sounds kind of intimidating.
It's definitely a mind bender, but also incredibly fascinating. Imagine a loaf of bread. Each slice represents a moment in time, past, present, and future.
Okay.
The block universe proposes that all these slices, all moments in time, already exist simultaneously, like a complete loaf sitting there.
Wait. So you're saying that everything that has happened, is happening, and will happen
Mm-hmm.
is already out there somewhere in this block universe. Does that mean our lives are predetermined?
Right.
Do we even have free will?
Those are huge questions that philosophers and physicists are still grappling with.
Yeah.
If the block universe is an accurate model of reality, it does raise those thorny issues of determinism versus free will.
Right.
But it's important to remember that the block universe is just one interpretation.
Oh.
It's not a settled fact.
Okay, so more questions than answers. Sounds like a theme in this deep dive, but I'm starting to grasp the profound implications of all this. If time is relative, if there's no universal now, and if the block universe might be a thing, it challenges everything we thought we knew about reality.
It certainly does, and the excerpts highlight something really important here. Even though we might not experience the extreme effects of relativity in our daily lives, these principles underpin our understanding of the universe on a fundamental level. They shape how we perceive space, time, and our very existence.
So how should we think about time in light of all this? It feels like everything we learned in school is crumbling.
I think the takeaway is that time isn't this external force ticking away uniformly for everyone. It's interwoven with space, motion, and gravity. Right. It's relative, dynamic, and mind-bendingly complex.
So instead of viewing time as this rigid ruler, measuring our lives, we should embrace its fluidity, its mystery.
Exactly. Recognizing the relative nature of time can be incredibly liberating. It encourages us to appreciate the unique perspectives of others, to marvel at the vastness and complexity of the universe,
Right.
and to approach our own lives with a sense of wonder and curiosity.
I love that. It's like we're being invited to explore this grand cosmic playground where time itself is flexible and full of possibilities.
Yeah.
But the excerpts also emphasize that while relativity might seem abstract, it has real-world consequences.
Absolutely. And one of those fascinating places where those consequences are on full display is near black holes. Remember how massive objects warp space-time? Well, black holes are like the ultimate cosmic warpers.
Right. We talked about how time slows down near them. What else happens near a black hole?
Think of it as a region where the rules of time and physics get pushed to their absolute limits. The gravity near a black hole is so intense that it distorts not only time but also light itself. It's like looking at reality through a funhouse mirror.
So black holes are more than just cosmic vacuum cleaners swallowing everything in sight.
Right.
They're like time-bending, light-twisting behemoths.
Exactly. And studying them could hold the key to understanding the very origins of time itself.
Right.
Some physicists even theorize that time, as we know it, might have emerged from a region of infinite density, like the singularity at the heart of a black hole during the Big Bang.
Hold on. Are you saying that our universe and time itself might have been born from a black hole? That's mind-blowing.
It's definitely a mind-bending concept. And while it's still highly speculative, it highlights how black holes can help us grapple with the most fundamental questions about the nature of time and the universe. They're like cosmic puzzles daring us to unlock their secrets.
Wow. I feel like I need to sit down and process all of this. We've covered so much ground from the basics of time dilation to wormholes, the block universe, and even the idea that our universe might have sprung from a black hole.
It's a lot to take in, but it's also incredibly exciting to realize that time, something we often take for granted, is so much more complex. And fascinating than we ever imagined.
I completely agree. It's like every time we think we're getting a grasp on time, the universe throws another curveball our way. But isn't that the beauty of science?
Yeah.
It constantly pushes us to question our assumptions and explore new possibilities.
Absolutely. And that's what makes exploring the nature of time so compelling.
Yeah.
It's a fundamental aspect of our existence, yet it's full of mysteries that we're only beginning to unravel. But even though we may never have all the answers, the journey of exploration is what makes it all worthwhile.
Okay, I have to admit, my brain is feeling a little fried right now. We've talked about time dilation, the lack of a universal now, the mind-boggling block universe, the tantalizing possibility of time travel, and even black holes as potential keys to understanding the origins of time itself. I feel like I need a nap just to process all of this.
It's definitely a lot to digest, but I think it's worth taking a moment to appreciate just how radically relativity has shifted our understanding of the universe. It's not just about abstract equations and theoretical concepts. It has profound implications for how we understand ourselves and our place in the cosmos.
You're right. It's almost as if relativity is a lens that allows us to see the universe in a whole new light. It's like suddenly realizing that the world is in vibrant color when you've only ever seen it in shades of gray.
That's a fantastic analogy. And I think that sense of awe and wonder is what we should carry with us as we continue to explore the mysteries of time and the universe.
Well said. Yeah. So to recap what we've learned so far, time isn't this rigid universal constant. It's warped by speed and gravity, leading to the mind-bending phenomena of time dilation and the realization that there's no single shared now.
Yeah.
We've explored the theoretical possibilities of time travel, delved into the enigmatic concept of the block universe, and even touched upon the idea that our universe might have emerged from a black hole.
It's been quite a journey so far, and there's still so much more to explore. But I think it's important to pause here
Okay.
and reflect on what all this means for us on a personal level.
Right.
If time is so relative, so dependent on our individual experiences and perspectives,
Yeah.
what does that actually mean for us? How should we think about time in our everyday lives?
It's funny how we started this deep dive wondering if clocks are lying to us,
And in a way, they are.
but not in a malicious way, right?
Exactly. It's more like they're showing us a simplified version of reality,
Right.
like a two-dimensional shadow of a three-dimensional object.
They give us our local time, our everyday experience,
Right.
but they don't reveal the full complexity of the cosmic dance happening all around us.
Precisely. We tend to think of time as this rigid ruler ticking away at a constant pace for everyone.
But what we've learned from relativity is that time is so much more than just the ticking of a clock.
Right. Absolutely. It's not this external independent force dictating our lives. It's woven into the very fabric of the universe.
Yeah.
Intertwined with space, motion, and gravity. It's relative, fluid, and mind-bendingly complex.
So where do we go from here? We've shattered our old ideas about time.
Yeah.
What replaces them?
That's the exciting part. We're left with a sense of wonder. A thirst for deeper understanding. We're challenged to reevaluate our place in the cosmos, to embrace the mysteries that still surround us.
The excerpts end with a thought that really struck me. Time isn't just something we measure. It's something we live.
It's profound, isn't it? It shifts the focus from time as this external force to time as an integral part of our experience. We don't just exist in time. We exist through time.
Our memories, our relationships, our very sense of self is shaped by its flow, or maybe I should say flows, since we've learned it's not the same for everyone.
Exactly. It's influenced by speed, gravity, our position in the universe. It's almost like we each have our own personal time signature.
So even though we can't quite grasp the full scope of time's complexity,
right,
we can appreciate its beauty, its mystery, and its profound impact on our lives.
Yeah.
That brings me back to something you said earlier, the liberating aspect of recognizing time's relativity. Can you expand on that?
It's about letting go of rigid perceptions and opening ourselves up to the wonder of a cosmos where time itself is a boundless playground. It allows us to appreciate the unique perspectives of others, recognizing that their now might be different from our own. It invites us to marvel at the vastness and complexity of the universe, understanding that time plays a role in shaping its evolution, and it encourages us to approach our own lives with a sense of curiosity and awe, knowing that our individual journeys through time are unique and precious.
That's beautifully put. It makes me think that maybe the true magic of time lies not in fully understanding it, but in embracing its wonder and letting it guide us on our journey through the universe.
I love that. It reminds me of something we touched upon earlier, that the block universe concept.
Right.
If the past, present, and future potentially exist all at once, does that mean time travel is just a matter of figuring out how to navigate those different points in time? Is it really as simple as finding the right cosmic GPS?
No, now that's a question that could keep us pondering for another entire episode. but I think that's a mystery best left for our listeners to explore.
I agree. We've given them plenty to chew on already.
So until our next deep dive, remember, keep questioning, keep exploring, and never stop marveling at the wonders of the universe, especially the enigmatic nature of time itself.
Beautifully said. The universe and time itself is full of surprises. Who knows what incredible discoveries await us just around the bend in the cosmic river of time.